Welcome back, everybody, to another episode of Gregtech Community Edition Modern. Last time, we ended up, I think we fiddled around with this. Can't remember. We did something important. Either way, we're just going to move forward. So today we're going to start by making ourselves the brand new coils. And I'm going to install them on this first, as it'll make making these coils faster. So I've got all of the stuff up and in here. I will say one thing kind of important here. Let's check on something. Oh, give me just a second. Totally have my guy not moving because it's not hearing me. Here we go. Now you can see it. So, one of the important things, liquid tungsten has 0 cells, supposedly, that it can move in. Its temperature is 3695, and I went and looked up the cells. I don't know if there's another thing to move it. The only thing I could think of is a portable fluid cell would work. But the highest capacity temperature-wise is the tungsten steel cell. That one still is at 3587, so we're still off by like 100. Just over 100 there. The titanium's even lower, the stainless steel lower, like all of them are just flat out lower. Yeah, so even the regular cells won't work. So you could literally only do bucket or like a portable fluid cell or something. Infinite water cell. What? What? That's crazy stuff there. I didn't even know that those things existed. That's pretty cool. Infinite water cell or infinite cobblestone cell. I mean, it makes sense, but like, that's still not something I expected. Anyways, getting back to what we're working on. We need our HSS-E wire and our tungsten carbide foil. So we'll just go ahead and pop all of that in. That should do a full 24 coils to replace on there. In the meantime, one of the other things that we were looking at trying to get done, hoping I have everything set up while we wait for those. Found out I'm actually going to have to push this wall out and change the cable orientation here. So we'll go ahead and pop that on over like that. And get ready to push this wall out one more. Because you need a 3x3 space, a 1x3x3 space on the outside of this item, otherwise it does not work. So we'll go there, there, like that maybe. That looks okay. Let's change this piece here. And boom. Okay. So, and the reason I wanted that is because we are going to make ourselves a turbine. So that we can figure out how these work. Show them off a bit. As well as actually be able to use them. So the gearboxes, I don't know what's holding up the gearboxes. Let's see. It's crafting the gears, but it didn't send them out. Probably because I made something for later on. I needed that thing for it. So there's that. Gearboxes are done. So now that we have our turbine casings, our gearboxes, we have a fluid input hatch, we have a maintenance hatch, we have the muffler hatch. We still need a few more things. Where is it? Not there. Oh. I think I left it in here. Turbine casing. So we got the turbine thing. So that, let me just check it all off my list I have. One, we need a rotor holder. That's what we need. Okay, so muffler dynamo. Input, yep, just the rotor holder. Now we need the current tier. Uh-oh, gotta go have to fix that. I guess we have something that's... Which one is it going into? I think it's going in over here. Oh no, if it is over here, it's fine then. Yeah, that's fine. Okay, so that's gonna do that. Now let's go see where we're at here. We got 6. See, and this is why it started at the beginning of the episode, because each one takes 30 seconds a piece. But that's not gonna be done till almost the end. And there is our stuff going off, and that's going to take the 150 seconds a piece. So while we're waiting for the rotor holder, let's assemble it. So things that I don't need to worry about can go near the bottom, which is exactly nothing. I need all of that stuff. So let us look. We want, at least I want to be able to just pipe the fluid in from right there. So that's going to be our output, or our input hatch. Let's lay our speak properly, and we'll be fine. Okay, layer our bricks down. Then we need these right in the center. We need our... Did I not... I have the dynamo there. Dynamo right there. And that's going to pipe directly into our energy acceptor. This is what this one is going to be for. It's going to be to replace our turbines over here. So now we can just grab ourselves one of these. I think I can pull this off now. And we should be fine energy-wise. And that is good. Okay. Do that. Boom. Okay. And now we can fill out our sides. We need one there. 1, 2, 1, 2. And then I wanted the machine face right there. Oh, I said that, and then I filled it in. So we want the machine face in right there. I'll probably put a half slab there so I can actually look at the machine face. Put it right there. Now I can still access it from here. Now we are going to need our input, which is going to be, like we said, on this side. We'll do the polyethylene pipe to go down. Attach it. And then it doesn't have to be pointed the right way, but it can be pointed that way is what I'd like to do. I have to hot swap that block later. So I want to get everything else ready to go. So we just need all of this. 1, 2. Oh, I sillily put that there. Those need to be the muffler hatch and the maintenance hatch. Or I could do the maintenance hatch right here, just like I did the other one, and I like that idea better. So do the maintenance hatch there. We'll do the muffler hatch on top. And then we'll put almost all of our casings in. And I think, just to appease my sensibilities, we're going to pop all of these off. And I'm going to go up and over. So that I can pop down here and look at this spot for the turbine casing, or the turbine holder. And so now I just gotta check. One of these things should have our recipe going. Looks like we're crafting 9 more ingots, which means we're working on that secondary batch that we need. At least I'm pretty sure that's what that means. Yep, almost there. This is precisely why I want the better coils. But as we said, the better coils are going to come through some time. And we are currently through just about 2/3. We're another 20 seconds away from 2/3 being done, since it requires 24 for this machine. So yeah. So I guess when we have a lull, I can actually talk about something I ended up finding out. So I ended up watching this YouTube video that pointed to a study, and whenever I see some stuff with studies, I usually go and read it. So, and a lot of the people that I watch tend to have like links in their thing to these studies, so you can go and read it. One of the things very interesting is that apparently a lot of the microplastic research stuff they've done for consumptions of microplastics have kind of possibly been not looked at thoroughly enough, because every single time that they do these tests, they usually use some sort of gloves, right? Well, it turns out, I want to say it's like butyl or something. I gotta look it up. But let me see if I can find the name of that again. Release. Mold. So it's called... So they use a mold release agent. Polypropylene is what it usually is. But that is, as we know here, watching this kind of video, I'm sure plenty of people know that anything with the... those things there basically are some sort of like, oh, I can't think of the name. Derivative of oil, basically something that we use oil byproduct. That's what I was thinking of. I'm like, it's on the tip of my tongue. But we need to get into making something here really quick, and then we'll go back to that. But basically, because they're coated in that when they are made, the microplastics from the gloves end up falling out onto anything that they're testing on. And so it turns out that even the clean ones that are supposed to be clean still have like 100 parts per million or something like that residue left over, whereas the other ones are all latex, nitrile, all of them are outrageous in the extra stuff that they have. So, kind of an interesting thing I found. We did get the large gas turbine up. Now we need turbine mechanics. So it does have... Large turbines are the most complex multi-block generators that you will find in Gregtech in the present day. Let's delve into turbines. This quest unlocks a new tutorial on turbine mechanics and the tips and tricks to learn more. So let's go look at that. So, large turbines. Rotors have a power and efficiency and durability and are based on tool stats. Power is a multiplier applied to the production of the turbine. This stacks multiplicatively with the rotor holder. Efficiency reduces its fuel consumption. This again stacks multiplicatively with the rotor holder. Durability is the lifetime of the rotor in seconds when the turbine is active. Rotor holders above the tier of the large turbine will multiplicatively double the production for every tier, whilst additively increasing the efficiency by 10% every tier. Okay? And then turbines can scale power production far higher than their base output, thanks to tiered rotor holders. The rotor can give a huge boost to fuel efficiency and power production. You will get a lot of satisfaction for setting them up properly. Yay. And some cons of large turbines. Turbines work off of inertia, which requires them to continuously run to achieve maximum power. Any excess energy produced will be voided. You will need to use large energy buffers and an advanced energy detector if you wish to stay efficient. They require a rotor, which will lose durability over time and eventually break. A little bit of math is required to get the expected results. The turbine's power of output affects both the fuel consumption and the EU per tick generation. It is calculated with the following formula. Production equals base EUT, so EU per tick, times rotor power, times 2 to the power of rotor holder tier minus turbine tier. So, okay. The efficiency reduces fuel consumption, but does not alter the EU per tick generation. It's calculated with the following formula. Rotor efficiency times 1 plus 0.01 times rotor holder tier minus turbine tier. Okay. And let's simulate a large steam turbine with the ultimate rotor and an EV rotor holder. Production equals 124 times 1.6 times 2, which equals 3276. Okay. And then efficiency equals 1.30 times 1 point. So it's 143% efficient. Therefore, steam consumption would be there. This is above a titanium boiler or a tungsteel boiler with 70% throttle. Okay. Next, we analyze the gas turbine with a chrome rotor and an EV rotor holder. Okay. Do all the math out. Same fuel consumption would produce that much EU per tick using 6 turbo gasoline. So yeah, that's why I want stuff like this. Finally, how about you check out the plasma turbine with a HSS-E rotor and ZPM rotor holder. Production is that much times 2.5 times 4, a load of power, and 216%. This is more than a ZPM amp. Okay, that is right. Plasma turbine. Okay. I think that's just doing this here. Pretty interesting. So, I did think I saw something that said that the rotor has to be, like, empty spot. So, let's go check our coils really quick. Because they should be done. And they are. Nice. So that means we can go ahead and replace our coils really quick. Oh no, 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 no. Oh. This is why I like to leave it on a 1x1 when I accidentally forget that. So let's go ahead and find all the stuff to put back. I need that there. Hopefully we didn't get maintenance hatch. Energy hatch is right there. Oh. But you almost need 2 of them, so you don't do stuff like that. And then we need this. One thing I will say, I do love the way this thing lights up when you're using it. We don't want columns, we don't want rows. Want 5. And then we can just do this, right? Sweet. We just need to get in there to grab that last 2 of those. There we go. There is our 24 RTM, and now we can put our HSG. Kind of crazy to see the efficiencies that they have over the other ones when you hover over and shift. But by replacing these coils, this is going to allow us to make HSE, I believe is the next one that we got to make. And those rotors are supposed to be some of the best ones, it said, until... Did I put the recipe in here already? I did not, so let's go look at that. HSS-E. Alright, so we need to make this stuff, which is going to use 14, so we want that one there, and then we need to market that out. We need to say, how much was it making again? Same 8 as the other one. So, put the ingot in, and we will make, I think it's actually 9 that it makes. And then we just need a pattern to encode. Alright. Now, the question becomes, how many of these do we need for the blade? Let's make sure I didn't accidentally put something over here with that in there, because it would be sadly tragic if it tried to go do stuff over there. So let's go ahead and start crafting some of the HSS-E. And let's do like, I don't know, 64. Oh, we need a way for it to know what to do with HSSG beforehand. So I guess we'll only be able to craft one batch of it. Recipe. Recipe and recipe. Oh, we can make the dust. Oh, but it does have to be in an EV mixer. I think I'd rather have it make the dust than use the built stuff. Let's go ahead and do that. Because then that means that we don't have it trying to cycle through and do more of those ingots when we don't want it to. When we want and clog up the recipe, basically. So HSS-E, the only other thing we gotta check is got the program circuit of 14. So one thing I wanted to show that was kind of cool. So one of the reasons to do multi-block structures for stuff like your mixer is that if we do the big multi-block structure mixer later on, you can put programmed circuits in there to let it also do the other recipes. You just have to make sure that it's not outputting all of the recipes at the same time, because if you do mix in recipes that'll mix together, then you'll have a problem. I do think there's a couple other occasions where you might have a problem where the only thing that's stopping it from making stuff that you don't want it to make. I mean, I guess... Actually, no, there's even a way to fix that. So the way you would fix that is you'd have it output into a buffer chest. That buffer chest would then be accepting into the machine with the exact amount of stuff for a recipe. And then it will do its recipe and spit the items out. So I guess you could actually just use these things to be able to have, or these multi-blocks to have a large multi-block thing on there and let it do its job. I do want to wait and see if we can actually get this thing going here. But in the meantime, let's look at rotors. So we could... This is what I wanted to see. So the power of it's going to be times 280 and the efficiency is really high on that one. We could do an HSSG rotor. Just don't want to do too much of, like, lower power stuff right now. I mean, yeah, I think we're just gonna wait for the HSS-E. And it looks like we need 8 blades and a long magnalium rod. Okay, so I'll be back. I'm gonna go set all of these up on auto craft. You'll have to craft up the plates, the screws, then the turbine, and then the turbine with the long magnalium rod to make a rotor. And I will be back when that is all set up. So, alright, so we're not back yet with the HSS-E stuff. Because we had one problem I ran into. You need liquid helium to cool this stuff. So it's just kind of stockpiling at the moment. But I can say we're almost there. I actually have my automatic system to start giving us the couple of the different stuff. So we currently are actually sawing one of those phosphorus doped wafers right now. It's pretty nice. I actually got it set up. It will automatically smelt, then come in here, and make it using the laser engraver, and then we'll send it over to get chopped back up and make the parts it needs. We'll probably soon set the stuff to come over here instead. In fact, I could technically set that up now, but it might mess up the recipe, so we're not going to worry about it for the time being. I think that's literally the only part that I'm waiting for to be able to fix that up. Just need to grab out the tools and do the maintenance. Structure is incomplete. Maintenance is fine. So, yep, pop those back on in. And as soon as we get the power thing out, so we're back to cutting again. That is still something I find really cool that it works that way. As soon as that's done, we can pop it on down and supply it with helium, which we can pipe over. We need to get some more cable. Let's do like 30 more. There is that. Just gotta fix the wire in. Okay, what are we missing? We've got an input and output. Do I have to have everything? Check this. Yeah, that liquid is still in there. So it is 2 blocks. Should have everything. Oh. Missing the output hatch. Duh. Output hatch. Now, we do need another input hatch, so let's grab that. Input hatch. Grab out these cables. I might be able to connect it from here as it is really close. And then right there. I just find that slightly annoying that you can't get it placed. You're trying to pipe it up. And there. The cables are done. The output hatch. The input hatch is also done. And there is that. Now we just need our export bus. Do an import and a storage bus as well if we want to. Although I guess if we do an interface, it's a little bit faster. So we needed our export bus. Is what I wanted there. So this needs to have helium, gas, there. Helium gas is what we're exporting. And hopefully as that fills up, that will give us what we need. We'll go ahead and put this here. And then we just need a storage bus. If I could spell right, that would be helpful. That's just so cool seeing this stuff like blink on and off over here. And then it's working back and forth. And there's the storage bus. Place that there, and then we just get our linking quartz fiber to power that on up. And there we go. It's now taking that helium. The only problem is it is now outputting the helium over here. So we do need this to change where it's at. So we're going to go ahead and do that once we've got it through everything. We need to change it over here so we can pipe it directly back into our old system. Probably right there. Just because we don't want to waste it. I'm pretty sure it's a 1-to-1 ratio, yeah. So we use it, we basically end up using half of it to cool each ingot. But we should see that our HSS-E is starting to make its way through now. Which I think it's crazy that we're still not through all of the smelts over here just yet. But it is working its way through. We'll have to actually go make our turbines out of a different material really quick. So let's go ahead and look at that. Main rotor. Okay. So what is another good one that we've got? I do have HSS-G. However, I do think that that one's probably not our best one to use right now. Tungsteel's a little bit expensive. Stainless steel wouldn't be too bad. And then we could replace it with the other one when that stuff comes online. So I think that's what we're going to do. I've already set up the magnesium rods for that. We have stainless steel screws on Autocraft already, which means we should just need stainless steel turbine. Recipe for this. And we'll do that one. Oh, it looks like we have it all on Autocraft already. So we just need that in an assembler. Does it need a... Keep doing this where I forget to look. It does. It's a forming press. That's right. That's why I built this one. So we got our forming press here. We'll put our... Oh, that's not why I built that. I built that for the class. So let's look at... How many do we need? We need 8 in an assembler. Let's go find the assembler with that one. And we will make one of these turbine rotors. Just get this going. And it says we're going to want to use a nice big battery buffer. So let's go ahead and get a battery buffer. Started. We will use a nice big 16-volt battery buffer here. So we need to grab our crafting table. That's what we need. And have it make those. And then we just need our aluminum wires. We can make by 8s, which means we need 8 of them to get the by 16s. So just currently, is it stainless steel's getting mixed up right now? Okay. I guess we do have to process quite a bit of stainless steel to make it up. We are still quite a good ways away. But just thinking about it, I guess it does take quite a bit, because it's 44 plus 38, 72. Okay, well, it's working on some other stuff. What is going on? Did I just chew through power or something? And so it's not... Why are we not working? This is confusing. What happened? Are we out of power over here? No. No. We get power in our battery buffers. What's going on that's causing these to not function? Oh. You know... The simple thing that got me before. And now they'll blaze through it 5 seconds apiece. That's what it was. Got it. Okay. But yeah, we're almost... We're actually still far away from getting that done. That's kind of crazy. That is a long time to process those. But that's fine. Those will all get faster as we get better coils, more power, more energy to input into there. So... It looks like we are making short work of this now that they're able to actually process it. And the best part is I can add those coils in to overclock these even more pretty soon, and then we can recycle these coils down into things like cracking units. And I even thought about this. I can actually stick this over here, and I totally didn't think about that part. Because I didn't realize that these were going to be overclocked. Well, I guess originally I wasn't going to overclock these, but I decided to anyways, because I'm like, well, I can just put battery buffers so that they can be overclocked for like 15 minutes like it's doing here. But clearly, it's actually kind of crazy that it doesn't seem to use that much power compared to these things, just to liquefy the helium. Where is our helium, by the way? I think it's over on the other side, so it might actually be gone already. We'll have to see. No, we still got quite a bit. That's good. That was one thing I was a little bit worried about with this. Although, we might be full up over here is why we're not crafted anymore, and that is exactly the situation. So let's pull the helium out. It's gonna take a second there. We'll let it keep going. And our rotor should nearly be crafted at this point. That is a lot more durability than it looked like. Wait. It's never gonna tell me it's crafted because it's not that. Oh, that's funny. We're gonna have to go fix that recipe, but let's go ahead and... That's pretty funny. I don't know why... That's crazy. Why did it say that? So I just have to let it finish crafting and then cancel it when it tries to schedule this because it's never going to find it. I wonder if there's like a glitch in the system? Because I would have sat here going like, where's my turbine? Yeah, see now it says it's not there. But it crafted the thing. So like, let's go grab the crafting pattern. What is that though? Like, why did it say neutronium when it's the stainless steel ones? That is weird. So now let's look at turbine. Okay, there we go. So now we should be able to slap that on in. I was kind of hoping that it would have like a thing behind it, but Now, if we take this block out, which we only have a few seconds to try this out, take this block out, insert the new block. Should power the machine up. It needs maintenance. We've got that. Boom, boom, boom. All done, and it is working. Oh, that's cool. That is cool. Now, it does not hook up to anything, so I'm a little bit not smart right now. We're going to hook it up underneath. So we're actually going to break the energy acceptor so we can place it on to have it automatically connect. Which it doesn't do, because it's not a Gregtech plug. Okay, so wires. Then we'll do that. Sweet. So now it says it's got to get up to speed. So this is where I wanted to kind of look at this. So yeah, it looks like it'll slowly get up to speed. Awesome. This is cool. Way cooler than I expected. Does it show the durability on it? Do I have to go... Oh, don't do that. I guess if it's on and you click on it, it does a durability issue. Like it smacks you. Basically, don't stick your finger in there. Can I stick my finger there? That's crazy. That's through the armor, by the way. Bruh, that's nuts. That's a lot of damage. Awesome. Well, now all that's left is to get a battery buffer on this thing, which is what I'm going to do. I'm going to place it here and then have the power be able to go in that way so that it powers directly into there, and I can figure out how to set it to shut off automatically. That is another one of those things that we are supposed to have. Where is it at? Gas turbines, there's like, there we go, advanced energy detector. The advanced energy detector is an RS latch for energy control. Slap it onto a battery buffer and set a minimum EU near 0 and a maximum EU near max capacity. The cover will output a redstone signal until the high threshold is reached, and then it will wait until the low threshold is reached to output redstone again. This is a must to automate inertia-based power generators such as boilers, and more importantly, large turbines. Now, my only question on that is, where does the redstone need to be to shut it off? Does it need to go up against this? Because if that's the case, we can set it up to do that. I just want to know. I could actually make a redstone torch really quick and try it out. So what happens if I place... that stop it? No. Okay. This is something that is good to know, because as soon as I get that up, I'll make sure it's working. Or just have redstone linked up to it. Not a block above it, I guess. That doesn't shut it off either, so how do I shut it off? Well, I will find that out, and I will show you when that is the case, and I figured out how it works. Wait. Yes. Yeah, no, I'll find that out when it works, when I get there. But thank you guys for watching. Now with the generator over here handled, we don't have to worry too much about power on this end for quite some time. And then the next thing that we have our HSS-E stuff being auto-crafted on the other end, which is one of the important blocks into getting not only the turbine structures, but it's going to be used for some of our multi-blocks, as I've seen before. So just using that, if we make it into sheets, I believe. And then we put it in the assembler. Yeah, so this is where we get our sturdy casings, and our sturdy casings are not useful. Hold on. I'm so confused. I swear this was useful somewhere else. Maybe it is only turbines. I just totally thought that we needed it for some stuff. Well, I guess we need it for the next cutter. I guess we'll find out. Thought it was used for the some of the multi-block structures, but I guess the HSS machine casing is not used in this particular mod pack, so maybe it's because I looked up the casing and clicked on the wrong one and thought it was that one. Anyways, again, thank you guys for watching. Please like and subscribe and leave a comment. You guys have a great day. Bye!